We're going to look at factoring the difference of two squares here. Now, we've looked at the product of the sum and difference of two terms, where we've had, let's see, where we've had something along the lines of A plus B times A minus B is equal to A squared minus B squared, if we remember that. So, when we're talking about these things, what we're looking at is talking about having, how do we look at these when we have differences? So, for example, this A squared minus B squared, we factor that out, we get an A term plus the B term multiplied by the A term minus the B term. So how does this work out for us? Well, let's look at an example here. Let's say we have x squared minus 25. We could think of this as x squared minus 5 squared, because 25 is 5 squared. So really, we're looking at the difference of two squares here. The difference being x squared minus 5 squared. So in this case, if we look at this, then all we have to do basically is we're taking our A term plus our B term, and then multiplied by our A term minus our B term. Okay, so let's look at another example. Let's look at something like 4x squared minus 1. Okay, and these all have to be differences. We all have to have perfect squares here. 4 is a perfect square, x squared is a perfect square, 1 is a perfect square. Okay, so if we're looking at this, this is the same thing as saying 2 squared times x squared minus 1 squared, in essence. So our A term is 4x squared. Well, if we want our A term there, and this is what we're saying, A squared minus B squared is equal to A plus B times A minus B. Well, we got to take essentially the square root. So we're looking at 2x here. We'll have 2x plus 1, because we have a 1 there, and 2x minus 1. And the big thing we can see here is when we have this plus and minus and the terms are the same, they'll cancel each other out. If we multiply this through, we'll get 4x squared minus 2x plus 2x. Oh, minus 1, not plus 1, minus 1. And our negative 2x and positive 2x cancel each other out, so what we're left with is 4x squared minus 1. We'll do a couple more quick ones here. Let's look at, let's see, let's do a 25a squared minus 9b squared. Right? 25 is a perfect square, a squared is a perfect square, 9 is a perfect square, b squared is a perfect square. So if we're looking at this, this is our a squared here, this is our b squared here. So really we're looking at 5a plus 3b, we're going to be 5a minus 3b. Because we're taking the square of 25, the square root of 25, which is 5, the square root of a squared, which is a. There's our a term. Then we take the b term, our coefficient is 9, the square root of that is 3. The square root of b squared is b. And then if we multiply these out, we get 25a squared plus 15ab minus 15ab minus 9b squared. We know these two cancel out, so we're left with 25a squared minus 9b squared, which is where we started at. Alright, let's look at one more last one here for this section. And we're going to have z squared minus 16 over 25. So again, our a term is z squared. Our b term, b squared, is 16 over 25. So if we want to take the square roots of each of those, the square root of z squared would be z. The square root of 16/25 would be 4/5. So basically what we're looking at is z plus 4/5 and z minus 4/5. Okay, so actually there's one more. I just saw one more, thought of one more I want to do. Now, let's look at this. Let's look at something where we have like y to the fourth minus 81. Well, y to the fourth is the perfect square of y squared. 81 is the perfect square of 9. So really we're looking at y squared minus 9, y squared plus 9. So if we do see perfect square binomials, the difference of, we usually can factor those pretty easily. Now, one thing we got to look at here is we have y squared minus 9, y squared plus 9. We ought to be able to see that this is again a perfect binomial. It's perfect square. It's a difference of two squares. Y times y is y squared. 3 times 3 is 9. So although we can't break down y squared plus 9, we can't factor that. We can factor y squared minus 9. And that would be y minus 3 times y plus 3. So even though we got to here and we had to factor for them, we could still factor this other one down into this. So we have three binomials here we're multiplying by to get this y fourth minus 81, because we have the square of a square here. Okay, so hopefully this helps with factoring the difference of two squares. The next one I'm going to be looking at the sum and difference of cubes. So we'll see you in the next video. Bye.